here. So let's take a look at an example. We're just going to focus on if something is spontaneous. So which of the following processes are spontaneous? Which happens naturally? Does a ball rolling up a hill, does that happen naturally? Well, probably not. A ball isn't going to roll up the hill on its own. B, the freezing of water at -3°C and 1 atm of pressure. So think about what temperature does water freeze at? Freezes at 0. So the freezing of water at -3, that would be spontaneous. For C, the freezing of water at 3°C. Well, at standard pressure, water doesn't freeze until 0. So freezing of water at 3 degrees would be not spontaneous. And then the decomposition of carbon dioxide into carbon and oxygen. Think about that one. Think about if that would be spontaneous or not. And then E, the dissolving of NaCl in water. So like we said, A is not spontaneous, B is spontaneous, C is not. And I want to focus on D and E. The decomposition of carbon dioxide into carbon and oxygen at room temperature and standard pressure. Well, if you think about that, think about carbon dioxide in the room. Is it decomposing into solid carbon falling on your head and oxygen gas? No. So that is not a spontaneous reaction. It does not happen naturally. And then E, if you put salt into water, it dissolves. We're assuming, it's just water and you're just creating saturated solution. But dissolving NaCl in water, that is spontaneous. So processes that occur spontaneously in one direction are not spontaneous in the other. And I had said that before. So think about this. Okay, if you dissolve NaCl in water, okay, that's spontaneous. However, when you are depositing the salt back out of the water, is that spontaneous? Well, it's not. Think about what you have to do. What do you have to do to get the salt back? You have to boil off the water. You have to put energy in. Okay, so that is not spontaneous. So these are just examples of, if something is spontaneous or not. So going back to the enthalpy driving force of a reaction is this example. So let's say you had this example on a quiz or a test. At 25°C, the delta H value for the reaction, gives you the reaction for the formation of water, is -572 kilojoules. Can you conclude from the sign of delta H that the reaction is spontaneous? So you might have a question like this, but instead of can you conclude, it might say, is the reaction spontaneous? From this, you cannot tell if it's spontaneous. Just by having delta H does not mean that you can tell if it's spontaneous. The only thing you tell from delta H is that this is an exothermic reaction. Many exothermic reactions are spontaneous, but not all of them. So you cannot rely on delta H to tell you if something is spontaneous. Now I want to look at some examples, right? We talked about all this conceptual stuff with entropy, but the best way is just to practice. So with example 3, it says for each of the following pairs, which has the greater entropy? Okay, so again, think about entropy in terms of disorder. Okay, which is more disordered? So A is carbon dioxide as a solid or carbon dioxide as a gas? Well, it's going to be carbon dioxide as a gas because your gas particles are more disordered. They're moving around much more. They're colliding with each other. They're colliding with the wall. So the gas molecules are more disordered. They would have a higher delta S. Okay, the numerical value of delta S would be higher. B says ammonia as a liquid or ammonia as a gas. So again, think about that. Well, you should say that it's ammonia as a gas for the same reasons as CO2. And then C says a crystal of pure magnesium at 0 Kelvin or a crystal at 200 Kelvin. So you want which one has the greater entropy? Well, it's going to be the crystal at 200 Kelvin. You could think of it one of two ways. At 0 Kelvin, entropy is 0, or the higher the temperature, the more the molecules move, so the more disordered they are and the higher the entropy. Okay, so example 4 asks you to predict whether delta S is greater than 0 or less than 0 for each of the following. So A, you have sugar, so solid sugar and water, and then it's dissolved. You have solid sugar, liquid water, and then you're putting it into solution. So when you put it into solution, when you dissolve something, you get more disorder, right? You're creating a solution. And when you create a solution, your entropy increases, which means your delta S is positive. It's greater than 0. With B, again, when you have sodium sulfate, it dissolves or dissociates into its ions. It's becoming more disordered, so it's also positive. And then with C, you have hydrogen and oxygen gas forming water vapor. Well, if you look on the left, you have 3 molecules of gas. On the right, you have 2. So are you becoming more disordered or more ordered? Well, you're becoming more more ordered. When you become more ordered, your entropy decreases, right? You are essentially taking away the disorder. So your delta S is less than 0. So these are the types of questions that I'm going to have you focus on today. Is we're going to focus on entropy being greater than 0, less than 0, more disordered or more ordered, and then also focus, like we looked at before, on something being spontaneous or not. Because then what we're going to do is we're going to use all of that information and we're going to continue to apply it in thermodynamics and look at Gibbs free energy and how that affects a reaction.